Hi students, welcome to the problem solving session on impulse response and transfer function of discrete time system. Let us see this problem. So this question is asked in AU 2010, right? So that is very good question. Let us solve this. Right? Discrete time causal system has a transfer function h of z is equal to this one. What we have to find difference equation of the system, pole zero diagram and the impulse response. So first thing is difference equation. Difference equation means everything will be in the n. So here everything is in z. So we have to take inverse z transform. That we have to keep it in mind. Pole zero diagram we can draw from h of z itself. Impulse response is h of n. So from h of z you have to take inverse z transform. Then only we can get h of n. That's what our impulse response. Right, here everything should be n. So what we have to do is first we take inverse z transform, then it will become n. Then we go and do remaining things. So what they have given h of z. H of z is given by h of is nothing but y of z divided by x of z that we know. That is given by 1 minus z inverse divided by 1 minus 0.2 z power minus 1 minus 0.5 z power minus 2. Yes, of course. Yes, same thing. So from this, what we have to do, let us take cross multiplication. So it will be y of z. You bring this side, y of z. I directly multiply 0.2 z inverse y of z minus 0.5 z power minus 2 y of z. That is equal to x of z minus z inverse x of z. Right? So my difference equation will be in y of n format. Right hand side remaining things will come. So I keep y of z this side, make everything go that side. So x of z minus z inverse x of z plus 0.2 z inverse y of z, right? And plus 0.15 z power minus 2 y of z. Now if we take inverse z transform, it will be simple. Take inverse z transform. Y of z inverse z transform is y of n. That is equal to x of z inverse transform x of n. This is minus z inverse x of z is x of n minus 1. This is 0.2 z inverse. So 0.2 y of n minus 1. Z power minus 1. So it is n minus 1. That is 0.15 y power z power minus 2. So it will be y of n minus 2. Simple. So this is what the difference equation. We got it. So answer for first subdivision. Okay. Now next we have to find pole zero diagram. Right. So pole zero diagram we have to draw from h of z itself. Right. So h of z is given by 1 minus z inverse divided by 1 minus 0.2 z inverse 1.5 z power minus 2. So if you take the factors, then it is easy to find poles and zeros. First make everything in terms of positive z. Okay, so multiply numerator and denominator by z squared. What will happen? Because y, the largest power is z, so z squared, z power minus 2. I want everything to be positive. So I multiply with z power 2. So it is z power 2 minus z. I multiply it in divided by z power 2. So it will become z squared minus 0.2z minus 0.15. Okay. So this we can write as z into z power minus z minus 1 divided by, if we factorize it will become z minus 0.5 z plus 0.3. Fine. Okay. So what will happen? Now we got poles and zeros. Right? Why? The poles is nothing but the denominator value of the value of z, which makes total function infinity. So when you substitute z is equal to so it is not 0.15, it is 0.5, right? We can see z is equal to 0.5. Z is equal to 0.5 is one pole, z is equal to minus 0.3 is another pole. So directly I can draw, right, this is z. So z is equal to 0.5. Here we have one pole. Fine. This is z is equal to 0.5. Real part of z. This and all you have to note down, right? Imaginary part of z. Z is equal to 0.5. Another pole at z is equal to 0.3. Let us assume it is smaller than this, so it is 0.3 minus 0.3 minus. So fine, I draw properly. Z is equal to minus 0.3, right? So this is a pole zero diagram, right? Okay, now what I need, this is what second part answer. What I need is impulse response. I have to take h of n. That means I have to take the inverse z transform. So I told whenever you want to take inverse z transform, bring one z downside here. So h of z divided by z. Okay, so that will be equal to, so z minus 1 divided by z minus 0.5, z plus 0.3. Okay, so take partial fraction and find it. What you get is, it will be minus 0.625 divided by z minus 0.5 plus 1.625 divided by z plus 0.3. So how I am getting? Take partial fraction. This is what h of z divided by z. Okay, now what you have to do? So bring this z this side now. H of z is equal to minus 0.625 z divided by z minus 0.5 plus 1.625 z divided by z plus 0.3. I brought this z for both. Okay, so now what is our h of n? You can directly take inverse z transform. I is z t. Inverse z transform of h of z is equal to h of n. That is minus 0.625 0.5 power n u of n plus 1.625 point minus 0.3 power n u of n. Why? We know the transform of a n u of n is equal to z by z minus a. Here a is equal to 0.5. So 0.5, this constant z by z minus a is having inverse the transform of a is 0.5 and u of n. Here a is equal to minus 0.3. So minus 0.3 power n u of n. This is the answer for third subdivision. I hope you understand this problem. If you have any doubt, please ask me in comment section. Thank you.